Hello everyone, I'm J1, very glad to be here to present our GAM coach, an interactive tool for user-centered algorithmic recourse. So as we all have known, machine learning has been increasingly used in high-stake domains, such as finance, criminal justice, and healthcare. And to promote responsible AI or machine learning, we have seen great strides explained for ML. So researchers have developed many techniques to explain the machine learning predictions to gain users' trust. However, those techniques often focus on data scientists, machine learning researchers, practitioners, and domain experts. And the end users who are being impacted by the machine learning systems are often neglected in machine learning ML research. And a recent paper also identified those users as everyday users, so they have limited machine learning background experience, and they have different goals and backgrounds when interacting with machine learning systems. And some researchers also categorized some different goals when we're trying to explain ML to everyday users, such as building trust, also allowing them to contest on unfair or wrong decisions made by machine learning systems, and also to provide recourse. And in this talk, I will focus on recourse. So what is algorithmic recourse? So some research defined it as a way to provide end users with different means to alter unfavorable machine learning decisions. To give a more concrete example, let's think about a loan scenario. So imagine a loan applicant trying to apply for a loan in a bank, and the bank using a machine learning model to make the prediction. And unfortunately, the applicant was rejected. And to help the user or the applicant to gain better understanding, also to alter the unfavorable machine decisions, the bank told the applicant, if your income were 50K higher, your application would be approved. So here, this statement is a counterfactual explanation, so it has the form of what if the input is some different values, and maybe the outcome prediction would be changed. So it's very popular to provide those counterfactual explanation as a way to provide algorithmic recourse. However, not all recourse are equal. Some recourse are very hard or even impossible to achieve. For example, in this case, maybe increasing the income by 50K is impossible for this applicant. And to help users to gain more helpful recourse plans, recently research focused on more actionable algorithmic recourse. So researchers propose different techniques such as minimizing the feature changes, prioritize high variance features, or maybe provide multiple plans to achieve actionable recourse plans. However, those researchers assume that developers know what constitutes actionability for all end users, and in practice that is not true. For example, we can think actionability is personal and subjective. For example, for some applicants, maybe they're okay with a smaller loan amount, but for some other applicants, maybe they're not. Some applicants, maybe they cannot change their home ownership overnight, and maybe for some applicants, it's easier for them to boost their FICO score. So you can see the actionability is very personal and it varies from user to users. And there is a dire need to have a new system to provide tailored or personalized recourse to different end users. To achieve that goal, we present GAM Coach, the first of its kind interactive tool to help end users obtain their AI decisions and to customize those recourse plans. So with GAM Coach, we enable a new recourse paradigm where user can provide their feedback and the bank or the other agency can provide new recourse plans based on their preferences. For example, in the same scenario here, maybe the applicants can tell the bank maybe the recourse plan is too hard and they're actually okay with a smaller loan amount. Then the bank will update the recourse plan and find an alternative recourse plan using the easier to change feature, for example, lowering the loan amount by 5K. And in this case, the applicant will be very happy with that recourse plan and will apply again in the future. And to achieve this goal, GAM Coach will focus on a model called Generalized Additive Model, or GAN model. So this is a glass box model, so it's very transparent. So we have 100% certainty of what's going on inside the model. So we know how the model makes predictions. And also the model is very popular in high-stake domains because it's a transparent model. And we develop a new novel recourse algorithm using integer linear program. So for more detail, please check out the paper. But by having this integer linear program, we can model the user preferences as linear constraints, and with some modern linear solvers, we can quickly solve the linear program to give the optimal recourse algorithm, to give the optimal recourse plan or counterfactual explanation for GAN models. And also with our algorithm, we can provide diverse solutions. However, for end users, by having algorithms is not good enough. They still need to have an easy-to-use interface to provide their feedback and also for the developer to communicate those recourse plans to end users. To that end, we designed develop GAM Coach, a user interface first of interactive visualization system to help a user to obtain their design AI decisions. And our tool is open source, and we have a demo, so you can try to trial our demo by visiting a link in the screen. So right now, I will give a demo of our tool. So GAM Coach is a web-based interactive tool users can access from their browsers. So in this demo, we'll use a loan scenario. So I have different input features to give a loan approval or rejection. And here's an example of how GAM Coach can suggest a rejected loan by applicants change their input feature to get a loan approval. So in the web sections, in the first section, we have some different features that will already be changed by GAM Coach using the default configurations. You can also hover over to see some different features. Here's a feature with some specified preferences. Here are all the default preferences, and here's the other features. You can also click different tabs to see different plans. By default, GAM Coach generates 5 default plans. You can hover over to see the prediction score until the threshold to getting a loan approval, which is 0.5 in this case. User can also click the feature card to see more details about different features. For continuous feature, we also visualize the value distribution for all the user in trained data set. So here the green means the suggested changes. User can drag around the thumb to see how some hypothetical value changes the model prediction. So one of the major features for GAM code is to help a user provide user input or their preferences. So imagine one user, they cannot change their loan amount, but they're okay to easily increase their FICO score up to 750. So to do that, we can tell GAM code not to change the loan amount by clicking the lock button, so new plans will not consider loan amount. And for FICO score, we can drag around to change the acceptable range to 750, and also change difficulty to easy to change. So the new plan will prioritize FICO scores. Optionally, user can also change how many features that a new plan can change. Here we change the number of features to 2. So after user clicks the regenerate button, so you can regenerate new plans according to those specified preferences. So here user can browse different plans by clicking the tabs. And for example, this one only uses FICO score, which looks a very good plan, so we can bookmark that plan by clicking the start button, so this plan is saved into our bookmarks. So this is about continuous features, as also see some other categorical features. For example, home ownership. So this category feature, user can also click the name to see how different categories change the prediction of the model. So imagine the user, maybe their family is buying a condo next month, maybe they can change the status of their input features. So maybe we can change to prompt the GAM code to use home ownership as a feature to change in the recourse plans. So we can click to change to a separate range, and also it's easy to change. Then again, similarly, user can also click the regenerate button to generate new plans with those new preferences. User can also browse the new plans by clicking the tab button from plan 11 to plan 15. And sure enough, in plan 12, we can see home ownership is changed by GAM code. So this is a good plan, so we can also start that plan to save it into our bookmark panel. And here's some researchers interested in some research. They have some idea of like receipts for counterfactual explanation for recourse, so the bank can guarantee maybe a loan approval if they achieve those recourse plans. So we also implement like the receipt using a verifiable algorithm. We use like PGP signature to make our receipt verifiable. For learn more details, please refer to our paper. After developing GAM code, we want to use it as a research instrument to learn how everyday user would use interactive recourse tool. So we conducted a user study with 41 participants where we found Amazon mechanic tricks. So similar to the demo with the loan application scenario, we'll have the participants pretend to be different rejected loan applicants and let them freely explore the GAM code until finding a satisfactory plan. So they can change the default plan, so they would not force them to use the configurations or any preferences. And then during the study, we log all the interactions, like which button they click and which timestamp, and also we have a survey at the end of the study. So by analyzing the usage log and survey responses, we want to answer 3 research questions. So first, we want to study the characteristics of different good recourse plans. Our findings validate many hypotheses from the existing recourse researchers. For example, we found participants that prefer actionable features. For example, found maybe it's easier for FICO to change FICO scores over employment length, so a lot more participants to choose FICO scores. And also participants prefer smaller changes. And also found the users that prefer beneficial plans that are beneficial beyond the recourse goals. So for example, one participant wrote, lower utilization is good for me anyway for what I know, so this seems like a best plan. And next, we want to discover the path. We want to study the path to discover good plans. So recall in GAM code, user can change the difficulty of features of a separate range of different features. So we found the majority of participants, they use the customizations. So found customization really can help them find good recourse plans. And we also find among those like the configurations, people have very, very different preferences. For example, in this chart plot, we visualize the top 7 frequent difficulty configurations. We found some features are more popular. For example, loan amounts more popular to add some preferences than other features. But even on those popular features, people have different preferences. For example, for some features, it's impossible to change the loan amount, but for other participants, also it's very easy to change the loan amount. Then we want to study like the role of interactivity in recourse. So in general, we found interaction helps prioritization. For example, one participant mentioned, I like how easy it was to make changes to priority of different things. And if in GAM code, user can ask what if questions to see the effects of changing one particular feature to the model prediction. By analyzing the logs, we found actually by asking what if questions, the participant is more likely to optimize that feature, which is statistically significant. And also it's more likely for them to choose satisfactory plans using the features that have asked what if question on, even though it's not significant on that second finding. Third, like in deploying the model in our study, so some features are not monotonically increasing or decreasing, so there can be some counterintuitive plans. For example, on some features, maybe the likelihood of getting a loan increased a little bit, then decrease, then increase, then decrease. So there are some weird hiccups during the recourse plans. And we ask participants to report those counterintuitive plans. And many participants reported. For example, the participant find one plan told me to increase the loan amount by $13, while other plan told me to decrease by $1,600. So there's some weird behavior for those recourse plans. So the findings also tells us like it's important to vet and fix the models before deploying those models in real life. Otherwise, participants can be puzzled by these recourse plans, and also there are some hacks to game the system to get a loan approval by only increasing your loan amount by $13. Finally, we discuss the limitation and future work for GAM code. First, our method and study can definitely be improved. For example, the researcher can generalize our methods to different model types, and also incorporate causality when generating new recourse plans. We also encourage researchers to engage with real users to see how do they use interactive recourse tool in real life. And some might argue that our tool has too much transparency, that the user might game the system. We acknowledge those concerns. We do see there's a tension between decision makers and decision subjects, and if the researchers can study what's the right amount of transparency to benefit both parties. And also I want to emphasize the need for user-centered recourse. As we all have seen from this talk, the users' preferences for recourse really vary from one to another, so it's very important to provide user-centered recourse. So if your user can think about the other mentality for those tools, maybe using a chatbot to provide interactive recourse, maybe user can predict the user preferences. So there are a lot of research opportunities in this area. And that concludes my talk. To learn more about GAM code, please read our papers and also visit our demo using the link in the slide. Thank you so much.